This is the Org M1 as it exists now on the new platform. It is entirely a homebrew project, mostly breadboarded. I cleaned it up here recently to remove some vestigial components and systems. Back here is the new memory system. It's actually a quad-channel serial memory system, which I know is delightfully ironic in a way. Power regulation circuitry, some basic input and output over here via direct I/O. Here's the core logic of it, and here's my display and power for it. Alright, so the whole system's on right now, but it's not actually running. So let me just go ahead and start it up. You'll get to see it run a very small program. Alright, so it was just 6 instructions long. It took and did a little bit of basic math. Specifically, it put 505 in register 1, then it put 444 in register 2, then it added registers 1 and 2 together, storing the result in register 0, and then it stored 37 in register 1, then it subtracted register 1 from register 0, storing the result in register 0, and you end up with the answer. Register 0 is actually shown in real time as this machine is running on the bottom row right now. So, I mean, you can see the binary result of all those math operations. Above it, right now, you can see the program counter. The way it works is kind of, I don't know how to put it. Every instruction will by default, or excuse me, let me back up. Every time it reads an instruction from memory, it increases the program counter at that time. So it reads an instruction, then processes that instruction. That's 2 separate cycles at least. The memory operation is actually a lot of cycles, but for any instruction which you don't wish to increase the program counter linearly, such as a halt instruction, you have to manipulate it. So like right now it's on instruction 1, 2, 4, 5, you know, the 6th instruction, so it keeps going up to 6, but the 6th instruction is actually halt, so it has to decrement the program counter 1. It's kind of a hokey way to keep it from increasing, but it works. So you can see up here, if it'll focus anyway, that it is actually hammering the memory. You're seeing some of the input and output from the memory device. The 4 bits on the right are the 4 channels in RX, and the 4 bits on the left are TX from the memory. Over here you see various things, like this is chip select, and there's a couple memory controller busy signals, and this one on the very end is heartbeat. The one next to it is actually the CPU state. Whenever it's dark, it's doing memory I/O. It's reading instructions from memory specifically. When it's bright, it's actually doing logic. And this whole board only refreshes at 100 frames per second or so. So you're just getting a sample of what the state is of the machine 100, 120 times a second. You're not actually getting to see everything happen precisely in real time, because if you did, like, a lot of the stuff you would never see. These lights over here would just be a shade of green. It wouldn't be flashing. So anyway, that's the ORG M1 as it is now. It's pretty exciting.